Okay, so today we're going to be learning 7.3 similar triangles. So this is right after similar polygons where we noticed we could find ratios from one side to another and determine if they were similar or not and then find missing information. So we're doing the same thing here except we're going back to those postulates of triangles. So our essential question for today is how can I determine if triangles are similar? We're going to talk about a couple postulates and determine if we can say that one triangle is similar to another. Our first similarity postulate is the angle-angle. So we're going to be looking at two angles to determine if one triangle is congruent to another. So the postulate states if two angles of one triangle are congruent to two angles of another, then the two triangles are similar. So based off of that, we're going to look at these four problems and we're going to see if they're similar, not similar, or cannot be determined. So our first example, we are given two angles. We are given 62 and 88. And then on the second triangle, we're getting 88 and 28. Well, that's awesome. We know 88 and 88 are definitely the same angle. But 62 and 28 definitely are not. So we need to find our missing information of these two triangles. Well, we know how to do that from last unit. We're going to take 180 minus the two triangles and we're going to get our missing information. So we're going to take 180 minus 88 minus 62 and we're going to see that this angle is 30 degrees. Okay? Now that we know that this angle is 30 degrees, we can kind of see it doesn't match 28, but we should still solve for that other angle. This angle we're going to find by 180 minus 88 minus 28 and see that it is 64 degrees. Since we have these two angles found, do any of the other angles match? They do not, so this is not similar. Even though we had one angle, we need a minimum of two. Okay. Now that we've determined that, we're going to move on to two. Same process. We have been given 58 and 60 for ABC triangle, and we've been given 60 and 62. But our 60s match, so that's already one down, but we need to find the other angle. So to do that, we must find the other angle by subtracting our 180 from the two angles we know. For this one, we took 180 minus 60 minus 58, and we're going to see that this is 62 degrees. That actually looks pretty awesome, because hey look, 62 and 62. Just in case, we are going to check this one by taking 180 minus 60 minus 62, and we are going to see that it is 58 degrees. Well, since a minimum of two angles are the same, then we know that this is similar. So these are similar. Angle-angle is fairly simple as long as you can determine two angles are similar through math or through postulates that we need to remember. We'll be able to figure it out. So we're going to do 4 and 6, I know the numbers are out of place, but I didn't like the others. So we're going to do 4 and 6. 4 and 6 says, I have a box and a box. And we know that a box means 90 degrees. So right there, we know that those two are the same. Well, we need to determine, can we find another angle? Well, we have a large triangle and a small triangle. This angle we're not certain of, and this angle we're not certain of. But what about this angle? Well, this angle is part of this triangle, the small one, and it's part of the big one. So does that not mean they match? So these have to be the same. They have to be equal. It's the same angle. So because we have the same angle based off of the picture and two 90 degrees, they are similar. So we had a minimum of two. I didn't have to really check those, but now that we know those two are the same, these two also have to be the same. So moving on to 6. Once again, we've been given that angle A and angle D are 90 degrees, so we already have one down. We need to determine, is there another angle they share? Well, if we remember back to our last few units, we have done the vertical angle theorem. And the vertical angle theorem states that if we have two angles that cross between two transversals, then angle ACB has to be the same as angle DCE. So right there it says I have one, angle A and angle D are the same, and then angle ACB and DCE have to be the same. So we found two angles that are the same. Therefore, these guys have to be similar. Moving on, now we have to determine which triangles are similar to this original triangle. So we needed to see if A, B, or C is the same. Well, let's first take a moment and look at number 7. This is an isosceles triangle because it says this side and this side are the same. We know that angle A is 70, therefore angle B must also be 70. And we can determine angle C as well. Again, we have two angles, so we're going to take 180 minus 70, and we're going to determine that angle C is 40 degrees. So we have broken down this triangle completely. We now know two sides are the same, and the angles are 70, 70, and 40. We now need to see if A, B, and C are also similar angles. Looking at A, it says this side and this side are the same. And it says my vertex angle is 40. Well, that matches that one. That's a good start. That means our base angles has to be 180 minus 40 divided by 2, which has to mean that these are 70 degrees. We have found a similar triangle. A is a similar triangle. Moving on to B. All we've been told is that 70 degrees is for this one, and that this one matches. So this has to be 70 degrees. So now we have to go, well, now that I know two of them, can I find the third? The answer is yes. Again, this is just review. So we have 180 minus 70, meaning this is 40 degrees. So B is also similar. Our next one is C. We can see that two sides are similar, but our vertex angle is 45. Does 45 match any of the last two we looked at or the original? It does not. Therefore, right away, I don't have to solve for anything and just say, nope, C does not work. Go ahead and take a break. You have just learned angle-angle postulate.